All right, so in the first set of problems, you're supposed to decide how many solutions there are, whether those solutions are real or complex, using the discriminant. So A is 1, B is 5, C is 3 in the first problem. So B squared minus 4AC is our discriminant. So it is 5 squared minus 4 times 1 times 3. So 25 minus 12, and the answer is 13. So that means there are 2 real solutions. In the second problem, A is 1, B is negative 4, C is 5. So again, B squared minus 4AC, negative 4 squared minus 4 times 1 times 5. That's 16 minus 20, which is negative 4. So the second one has no real solutions. It has 2 imaginary solutions. Third problem, A is 1, B is negative 8, C is 16. So it's 8 squared minus 4 times 1 times 16. That's 64 minus 64, which is 0. So this one has 1 real solution. So the difference between the 3, the last one, means that the parabola will come down, touch the x-axis just once. In the first one, the parabola will go through the x-axis and then come back up through the x-axis again, so it'll touch it twice. And then the one in the middle, the parabola will be completely above or below the x-axis, so therefore there's no real solutions, but there will be 2 imaginary. So in this set of problems, you're supposed to decide which way to approach finding the x solutions. You may not necessarily need a factor. So in the first problem, I would probably add 16 to both sides. You get 2x squared is equal to negative 4. And then divide both sides by 2. So x squared is equal to negative 2. Now the reason I would do this is because I just have one variable, which is the x squared, and I'm going to solve for x. Unlike the last problem, which if I expand out the x plus 2 quantity squared, I'm going to have 2 variables, an x squared term and an x term. So anytime I see a single variable like the first or the second problem, I would suggest going through and just solving for the variable. So here I would square root of both sides. And that's going to create a plus or minus situation on the right side. Because the square root of 2 has a factor of negative 1 in it, square root of negative 2 has a factor of negative 1 in it, we'd separate that into the two factors. 2 does not have a perfect square factor. Actually, the first number we're checking is 4. So the final answer here is plus or minus the I root 2. The square root of negative 1 is I. In the second problem, I would approach it the same way. I would add a 2 to both sides to get rid of the minus 2. So I have x squared over 3 is equal to negative 3. And then, as I have a division problem, I would multiply both sides by 3 to get the 3 divided by 3 is 1. So the left side becomes x squared is equal to negative 9. Like the previous problem, I would take the square root of both sides, so I end up getting just x on the left side. So it's going to be plus or minus the square root of negative 9. And that's going to have a negative 1 and a 9 factor. 9 happens to be a perfect square, so I don't need to try to see if I can break the 9 down further. So x is equal to plus or minus the square root of negative 1 times the square root of 9. So x is equal to plus or minus I times 3. Square root of 9 is 3. So the final answer is plus or minus 3i. In the last problem, first thing I would suggest doing is finding the answer to the x plus 2 squared. So we're going to x squared for x times x, 2x for 2 times x, 2x in the bottom right corner for 2 times x, and then 2 times 2 is 4. So we end up with is x squared plus 4x plus 4 is equal to negative 16. Again, I want to solve this problem either by factoring or using the quadratic formula. So quadratic formula requires the equation to be set equal to 0. And if I'm factoring as well, it needs to be set equal to 0. The factors of 20 are 1, 20, 210, and 4 and 5. And I'm trying to get a 4. So if I add and subtract, I'll get 19. If I subtract 21, if I add 8, if I subtract 12, if I add 1, and 9, if I subtract and add, there's nowhere where I get a 4. I get a lot of other choices, but not 4, which tells me this is not factorable. So quadratic formula is the way we go. So A is 1, B is 4, and C is 20. I'm going to stop there. Again, use the quadratic formula to figure out the answer to the last problem.